Hello everyone, my name is Haziq and today I am going to be teaching you one of the topics in mathematics which is called network and graph theory. Without further ado, let's get started. First of all, in this topic, we are going to learn about network. Graph is used to represent data consisting of discrete objects and to show the relationship between these objects in a simple graphical manner. A graph is interpreted as a series of dots, either linked or not linked by lines. Dots of the graph are known as vertex, and each line that joins two vertices are known as an edge. Here are some of the symbols that we will be using or found in this topic. V for vertex or dot, E edge or line or arc, D degree, and the symbol for sum. This is a simple graph. The line connecting these two vertices is called an edge. This dot right here is called a vertex. A simple graph has no loops and no multiple edges. The sum of degrees is always twice the number of edges. Let's look at this example here. Based on the simple graph given, determine the set of vertices and number of vertices, set of vertex pairs and number of edges, and the sum of degrees. So, the set of vertices will be written like this, and don't forget the curly bracket in the beginning and at the end. Also, when you count all the dots, you will get 6. Therefore, the number of vertices is 6. Then, the set of vertex pairs is written like this. Make sure you have the curly bracket in the beginning and in the end, and your answer should be written in paired orders. Also, when you count the number of edges, which are the lines, you will get 7. Therefore, the number of edges is 7. Finally, the sum of degrees is always twice the number of edges. Therefore, we multiply 2 with 7 as 7 is the total number of edges that we got from the graph. So, 2 multiplied by 7 is 14. Therefore, our sum of degrees will be 14. Next, we are going to learn about multiple edges and loops of a graph. Remember this simple graph from earlier? Well, if we add another line between vertex P and vertex T, it becomes multiple edges, meaning that between vertex P and vertex T, there are more than one edge. Also, the circle at vertex Q is called a loop. Here's the difference between multiple edges and loops. Multiple edges involves two vertices, meanwhile, loops involve one vertex. Multiple edges are connected by more than one edge. Meanwhile, the loops, which is an edge, is an arc that starts and ends at the same vertex. Next, the sum of degrees for multiple edges is twice the number of edges. Next, for loop, each loop adds 2 to the degree. Let's look at this example. The diagram on the right shows a graph with the loop and multiple edges. State the set of vertices and number of vertices, set of edges and number of edges, and also calculate the sum of degrees. So the set of vertex is written like this. Don't forget the curly brackets in the beginning and at the end of your answer. And the number of vertices is 6, as we can count from the graph. For the set of vertex pairs, make sure your answer must have curly bracket in the front and in the end. And also, for the multiple edges, you should write your pairs twice, and for the loop, you should make sure that the vertices are both the same. For the sum of degrees, you should count the edges for each of the vertices individually. Therefore, your answer will be 20. Next, let's learn about a directed graph. As you can see here, we have a graph of multiple edges and loops. But if we add some arrows to it, it becomes a directed graph. A directed graph is a graph in which a direction is assigned to the edge connecting two vertices. Based on the direction of arrows, it can be seen that edge 4, vertex P is the initial vertex and vertex T is the terminal vertex. Edge 5, vertex T is the initial vertex and vertex P is the terminal vertex. Lastly, edge 2, Q is the initial and terminal vertex because it's a loop. Let's look at this example. For a simple graph, which is directed, this is how you calculate the vertices, edges, and sum of degrees. Make sure you get the order of the edges correct. Also, take note of the degree in and degree out. If degree in, it means the number of edges going into the vertex. If it's degree out, means the number of edges coming out from the vertex. And for a loops and multiple edges directed graph, this is how you calculate the vertices, edges, and sum of degrees. Keep in mind that to calculate the degree of a loop, it's always 2, no matter if it's directed or undirected. Next is a weighted graph. As you can see here, we have a simple graph. But what if we add some distance to it for each of the edge? It becomes a weighted graph. It could be a directed graph or an undirected graph. And also, weighted graph, the edges are associated with a value or a weight. For examples, the weight could be distance or time. Let's look at this example. The diagram on the right shows one-way paths that Izaro can choose for his running practice. Vertex V1 is the starting position and vertex V5 is the ending position before he goes home. Determine the shortest distance from V1 to V5, the longest distance from V1 to V5, and the vertices that must be passed through if the distance of the one-way run is between 1.4 kilometers and 2.1 kilometers. So from the diagram, the shortest distance is from V1 to V2 to V5. Don't forget to calculate the total distance and also show the route. So for the longest distance, just see which path adds up to the biggest value. Therefore, the biggest value is from route V1 to V2 to V3 to V4 to V5. And the total distance, which is 2.5 kilometers, is the longest distance. For the vertices that must be passed through if the distance of the one-way run is between 1.4 kilometers and 2.1 kilometers, just look at the graph and see which route that adds up and the product is between 1.4 kilometers and 2.1 kilometers, and that is your answer. Next is subgraphs. As you can see here, we have graph G. So this picture right here is a subgraph of graph G. Then this picture right here is also a subgraph of graph G. Basically, a vertex of graph G is a subgraph of graph G. An edge of graph G along with the vertices it connects is a subgraph of graph G. And each graph is a subgraph of itself. Notice that both the subgraphs on the right has the right orientation of the vertices and edges. Make sure that the orientation of the vertices and edges match its original self. If it's not, therefore, it is not a subgraph. Now, let's look at this example. Determine whether diagram 1, diagram 2, diagram 3, and diagram 4 are the subgraphs of graph G. Look at the images closely. So, is diagram 1 is a subgraph of graph G? Yes, because the vertex pair for edge E5 is the same. Next, do you think diagram 2 is a subgraph of graph G? No, because the position of loop E2 is not on vertex Q. Next, is diagram 3 a subgraph of graph G? No, because the edge connecting vertex P and vertex S is not E3. Lastly, is diagram 4 a subgraph of graph G? No, because the loop and the edge connecting vertex Q and vertex R are completely wrong. Last but not least, is a tree. No, not the trees from the jungle or the forest. Let's say we have this graph right here. Graph H. So basically, a tree of the graph is a subgraph of the graph with the following properties. Number 1, it must be a simple graph without loops and multiple edges. All vertices are connected and each pair of vertices is connected by only one edge, and then the number of edges is equal to the number of vertices minus 1. So, looking at graph H, we know that it is a tree because all vertices are connected, every pair of vertices is connected by one edge only, no loops or multiple edges, and the number of edges is less than the number of vertices by 1. So, let's look at some examples, shall we? Determine whether each of the following graphs is a tree. Hence, justify your answer. So, A is not a tree because it has 6 vertices and 7 edges. Also, each pair of vertices can be connected in various ways. Remember, a tree, the number of edges needs to be less than 1 from the number of vertices. Next, B is a tree because it has 6 vertices, 5 edges, and also each pair of vertices is connected by only one edge. How about C? it is a tree because it has 6 vertices, 5 edges. And also, same as B, each pair of vertices is connected by one edge. D, it is not a tree because it has 6 vertices and 4 edges. And also, vertex T and R are not connected to the other vertices. So that is all I have for you guys today. Hope you guys enjoyed the video, and if you did, make sure to give this video a big thumbs up. And as always, thanks for watching.